Morning students, Sairam, this is Megha Miss here, and last presentation we started with a new lesson number 8, metallurgy. We have seen session 1. In the session 1 we just saw about the introductory part of what metallurgy we are going to study about. We have seen about the elements. They are divided as metals, non-metals and metalloids, which I have already studied, right? And then we saw about the chemical properties. I told you that physical properties you don't have for this year. It has been skipped out, but we are going to study about the chemical properties, and we started the chemical properties of metals. Yes, in that we saw different types of reactions. I told you to practice the reactions in your notebooks. We saw about the reactions of the metals with oxygen, reaction of metals with water. Also there are some exceptions. Some of the elements, they do not react with water, but they react with the steam. Yes students, and we studied about the reactions with the acids, that is hydrochloric acid we saw, right, that chloride salts are formed. Okay, so we'll proceed with the next type of the reaction, and the reactions of metals we will continue. And this time we are going to study the reaction of metals with nitric acid. Okay students, now nitrate salts of metals are formed on reaction of metals with nitric acid. Okay, so which students, which salts are formed? Nitrate salts. Okay, various oxides of nitrogen, N2O, NO, NO2 are also formed in accordance with the concentration of nitric acid. Okay, so how much concentrated acid is, that will be depending. Okay, formation of the the various oxides of nitrogen. Okay, so you can see here, if you take copper Cu in solid state plus 4HNO3 concentrated, you get CuNO3 twice plus 2NO2 plus 2H2O. Okay students, so you are going to learn again. You have to practice the reactions, then you can answer. Okay, then next, now here we first, in the first reaction you took concentrated, okay, nitric acid. Now in the next reaction, if you see, you have 3Cu, okay, plus 8HNO3, which we are taking it as dilute. You get the formation of CuNO3 twice, same nitrate salts you are getting, copper nitrate is formed. Okay, plus 2NO, that is a gaseous, okay, plus 4H2O. Okay students, so see, both reactions you will get the formation of the copper nitrate salt, which is our main compound which we require. Okay, I hope you understood the reaction of metals with the nitric acid. Here we took the metal, that was copper. Okay, we'll proceed. Now what is Aqua Regia? Now what is the students Aqua Regia? Aqua Regia is a highly corrosive and foaming liquid. Foaming means continuously vapors are coming out. Okay, it is one of the few reagents which can dissolve the noble metals like gold and platinum. Okay, you know noble metals, they do not react easily. Okay, but this Aqua Regia has got the capacity to dissolve them. Okay, Aqua Regia is freshly prepared. Yes, it is always freshly prepared students, by mixing concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So if 3 ml I am taking HCl, then 1 ml I will take the nitric acid. Like this, the proportion should be always 3:1. Then only we will call it as Aqua Regia. That solution what will be formed. And this Aqua Regia solution, you will remember, has the capability to dissolve the noble metals like gold and platinum. Okay students, I hope Aqua Regia is clear to you. Okay, so now reactivity series of metals. Now all the metals have got the different capability to take part in the chemical reaction. Okay, now see, we have seen that reactivity of all metals is not the same. However, the reagents oxygen, water and acids are not useful to determine the relative reactivities of all the metals, as all the metals do not react with them. Okay, we can't just use oxygen, water and acids to tell how much a metal can react. Okay, the displacement reaction of metals with solutions of salts of other metals serve this purpose. So we have to study the displacement reaction, which you have already studied in the chemical reactions part. Okay, So we'll see. Scientists have developed the reactivity series by doing many experiments of displacement reaction. Yes, the arrangement of metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Okay, so the arrangement of the metals in the increasing or decreasing order of reactivity is called the reactivity series of metals. Okay. Metals are divided into the following groups according to their reactivity. What are those groups, students? Highly reactive metals, moderately reactive metals, and less reactive metals. Okay, so you can see here this particular reactivity series of metals. This diagram is given in your text. Please go through it. Different metals are seen. You can see here potassium, starting with potassium, sodium, lithium, calcium. You can see they react with water and their reactivity, you can see it is higher. Okay, then you have magnesium, aluminium, zinc, iron, tin, lead. Okay, all this reacts with acids. Okay, and they are in between. Okay, then you have copper, mercury, and silver. Okay, you will see that they are reacting with oxygen. Okay, you can see the green color arrowhead. Okay, and gold, you will see it is the least reactive. As we have seen, we require an Aqua Regia as a compound, right, to make this gold dissolve. Okay, students, so this is the table. You just remember here, you just have to remember the metals. They are divided into the three groups: highly reactive metals, moderately reactive, and less reactive. Okay, students, we'll proceed. So now the next type of reaction, we will study the reaction of metals with non-metals. Okay, now noble gases like helium, neon, argon do not take part in the chemical reaction. You know, students, the reason. Yes, because they are stable, right? Their last orbit is a stable. Octets are complete or duplets are complete. Okay, so far we have seen from the reactions of metals that cations are formed by the oxidation of metals. Yes, if we look into the electronic configuration of some metals and non-metals, it will be seen that the driving force behind a reaction is to attain the electronic configuration of the nearest noble gas with complete octet. So whenever the reaction is taking place, always the stability will be attended, and that stability will be the near to the electronic configuration of some of the noble gas. Okay, metals do this by losing electrons, while non-metals do it by gaining electrons. You know this. The outermost shell of noble gases being complete, they are chemically inert. Okay, they do not take part in the chemical reaction. So noble gases, you can also call them as inert gases. Okay, we have seen in the last standard that the ionic compound sodium chloride is formed. You know this. Now it is learned by heart to you, right? As sodium metal gives away one electron, while the non-metal chlorine takes up one electron. You have studied the reaction also. 2Na plus Cl2, which is a non-metal, you get an ionic compound to NaCl. So see here, a metal is reacting with a non-metal. Similarly, magnesium and potassium form the ionic compounds MgCl2 and KCl respectively. Okay, student. So whenever you remember it is asked reaction of the metals with non-metals, simply write about the formation of sodium chloride. Okay, or you can write the formation of magnesium chloride or potassium chloride. Okay, students, should we proceed? Okay, let's see. Now the chemical properties of non-metals. Now here we complete with the chemical properties of metals. We have seen different types of reactions. I told you, please, I hope you are making a note of it and practicing the reactions in your notebook. Okay. Now non-metals are a collection of elements having less similarity in physical and chemical properties. Okay. Non-metals, they are also called as electronegative elements. You will remember, students, as they form negatively charged ions by accepting electron. Yes, chlorine, now only we saw the example, sodium chloride, right? Chlorine being a non-metal, it is accepting an electron. So they are the electronegative elements. Okay, students, we'll proceed. First we are going to see again reaction of non-metals with oxygen. We have seen reaction of metals with oxygen. Now we will see non-metals reacting with oxygen. Generally, non-metals combine with oxygen to form acidic oxides. Okay. In some cases, neutral oxides are also formed. We'll see them. Okay. So C plus O2, complete combustion, you get formation of CO2. Okay, that is acidic in nature. Okay, students. CO2 is a non-metal. 2C plus O2, partial combustion, means not I am totally total combustion doesn't take place. You get the formation of 2CO, which is a neutral. Okay. S plus O2. Okay. Combustion, you are going to get formation of SO2. Okay. That will be acidic again. Okay. So some of the non-metals, they form oxides, but some oxides are acidic, some are neutral oxides. Okay, students, and it depends upon the conditions: complete combustion, partial combustion, or combustion. Okay, please write the reactions properly, practice writing the reactions. Okay, now second we are going to see, that is the reaction of non-metals with water. Okay, generally non-metals do not react with water except the halogens. Halogens will react with water. Okay, student. For example, chlorine on dissolving in water gives the following reaction. What it is forming? Cl2, which is gaseous, plus H2O, which is liquid we are taking. Okay, chlorine gas it is. We will write Cl2. Okay. Then what we are going to get? HOCl, which is aqueous, plus HCl. Okay, so it is getting chlorine, it is dissolving in water, and it is giving the formation of this. Okay, I hope it is clear to you. Okay, the reaction you are going to study. Now third we are going to study, that is reaction of dilute acids with non-metals. Now we are going to see dilute acid when it reacts. Okay, generally non-metals do not react with dilute acids. Non-metals, they will not react. Halogens again are the exceptions. Okay. For example, chlorine reacts with dilute hydrobromic acid by the following reaction. You will see Cl2, which is a gas, plus 2HBr, aqueous, that is hydrobromic acid. You will get formation of 2HCl plus Br2. Okay, students. So please go through the reactions properly. One reaction is enough to you to remember. Okay, now reactions of non-metals with hydrogen. Okay, now non-metals react with hydrogen under certain conditions. Under certain condition only this takes place. Okay, such as proper temperature, pressure, and use of a catalyst. Okay, you know catalyst we are using. What is a catalyst? You have studied. Catalyst is nothing but we are adding it to the reaction to increase the rate of the reaction. Okay, students, it will not take part in the chemical reaction. Okay, the catalyst, it will not take part in the chemical reaction. So you can see S, okay, sulfur plus H2 will give you hydrogen sulfide, H2S. Okay, N2 plus 3H2 will give you ammonia to NH3. Okay, so you will see that non-metals, they react with hydrogen under certain conditions, and then only they form the compounds. Okay, I hope till here it is clear to you. Okay, students, so we will see what we have studied today. Okay, we have come to the end of today's presentation also. We'll just do a recap. You have studied about reaction of metals with nitric acid. We saw, yes, we saw that, yes, copper nitrate was formed. Yes, we have taken the metal as copper, and it depends upon the concentration of nitric acid. Yes, we have seen. Okay, reactivity series we have seen. Depending upon the reactivity series, metals, they can be highly reactive metals, moderately reactive metals, or they can be least reactive metals. Okay, three classifications are there of the metals. Then you saw about the reaction of metals with non-metals. Yes, simple formation of sodium chloride, you will remember. Na, that is sodium, is your metal, chlorine is your non-metal. They both react to give you an ionic compound. Remember, that was NaCl. So reaction of a metal and non-metal will give you a formation of a ionic compound. Okay, like that you can get MgCl2 also and KCl also, remember. Okay, then you saw reactions of non-metals with oxygen. You saw water, you saw that non-metals, yes, they react with oxygen and they can form the compounds which may be acidic oxides, neutral oxides, right? Then we saw about the reaction of nonmetals with water. Nonmetals do not react with water, but the exception are the halogens. Yes. And then we saw with the dilute acids again, halogens react with dilute acids. And then we saw with the reaction with the hydrogen. Okay. Yes, students, I hope whatever part we studied today, all our reactions in this chapter, please keep on writing the reactions, practice them. Okay, try to find out the products by writing the reactant parts and try to find out the product part on your own. Okay, so you can get a habit of what you can say, guess the products also. Okay, so we'll meet in the next presentation. I hope whatever part we have studied today, you will go through it properly and study well. Okay, so thank you, students. Take care.